I'm ready. Okay, hello. That was some of my professional warm-ups that I do before I video. Apologize for that. Well, good morning. Here we go. I like to warm up with a little bit of Brugger's coffee. Come on, Brugger's, throw me some cash. Makes me do mathematics about 95% accurate. Find a mistake, let me know, please. Put it in the comments. Be nice about it. Man, I gotta spit on myself. Here we go. Let's get started. Alright. This is just a warm-up. Let me grab a little highlighter. It says warm-up. I don't know why I'm in that. Warm-up. So we shouldn't have any issues with this. Let me get rid of this. If I can get rid of that. A little more real estate. Good. Alright, hi kids. Good morning. You guys getting sick of watching my videos? I hope not. Better not be. Alright, let's talk about triangles. Triangles. Anybody sick of a triangle? Triangle is the strongest shape there is. Gotta love triangles. Look around. Triangle A, B, and C. And they give us angle A is 30. And they give us angle B is 65. And they want, we know BC is 10. That's BC. And they said find AC to the nearest 10th. Looks like I have angle, side. Do you agree? I hope you agree, because if not, go back and smack your geometry teacher from last year. Angle, and a side. So angle, side, if I'm not mistaken. I could be, who knows? I make a few mistakes. We're going to use the law of sines to solve triangles. Well, we've been doing law of sines. That was on the last unit. A little review. Law of sines says we're going to put 10 over the sine of 30 is going to equal B. That's B. That's side there, B. Ooh, maybe I should just do this whole video in a little southern accent. That might get annoying. Keep a couple of you awake, a little irritated. Yeah. I done heard that when I saw something like this, that's out there, I do a little cross multiplying. Ooh, I had to spit a little bit when I did that cross multiplying. Okay, even I'm annoyed by that. 10 times sine 65. All we're doing is cross multiplying here. Good. We're looking for B. Don't hit in. Don't touch your calculator yet. This is just sine of 30. This is just sine of 30. So what we're going to do is now we're going to now we're going to grab our calculator. I hope I have that available. Should be around here somewhere. There it is. We're going to hit 10 sine 65. 10 sine. I like sine because I just have to press enter. 65. I probably should put 10 times. I don't know if this thing's going to like that 10 times. 10 times sine of 65 divided by sine of 30. Now, when I press enter, notice I didn't use control division, which I normally should do it, but I didn't do it. I don't know why. But when I press enter, it should look like 10 sine 65 over sine 30. Yes, it does. See how pretty this looks right here? Oh, it's so pretty. And it looks like we get 18.126. 18.126. 18.126. Round to the nearest tens place. I'm going 18.1. Let me check my notes. Make sure I didn't make anything stupid, because I like to make mistakes. Oh, yeah. There they are. My beautiful notes. Don't you wish you had my homework assignment? Oh, these are notes. These aren't the homework assignment. Damn. Ooh, said the D word. All right. Let's see, another triangle problem. Let's see what we got here. I'll draw it up here. A, B, C. Angle A is 35. Little a is 10. And little b is 13. Uh-oh. This is angle. I better put some dots in there. Dot, side, which you're not allowed to prove triangles congruent by. However, it means we're going to use the law of sines again. So, let's get going. 10 over sine 35 is equal to 13 over sine of b. Now in your brain, get that one brain cell rattling around, find it. In your brain, when you see that it says sine of b, this is sine of b, somewhere in your brain you have to realize, oh yeah, eventually I'm going to be using inverse sine. Somewhere around there I'm going to have to use inverse sine. So 10 times sine b is equal to 13 times sine 35. Divide both sides by 10. And I get sine of b is equal to this. So sine of b is equal to, let me leave a little space, 13 times sine 35 over 10. But what I just said a couple seconds ago was we're going to have to take the inverse in order to find out what b is. So in order to get rid of this b, we'll do the sine inverse of this side. Sine inverse, but those just cancel. Ka-ching, ka-ching. Not necessary that you show that work. I do it just so people in the math nerd world don't yell at me. And I'm going to do sine inverse of that whole mess all at one time. Let's see if I can handle it. Let's see if I can do it. Man, these cables are getting in my way. Alright, I don't even remember what I had. Alright, so we're going to start with sine inverse. Sine inverse of a fraction. I'll do control division now just to get the fraction. And 13 sine 35. 13 sine 35. What just happened? Enter. 13. I forgot the times again. I don't know why. Probably because I'm lazy. 13 sine 35 divided by 10, right? Wasn't it divided by 10? Divided by 10. So the inverse sine of 13 times sine 35 divided by 10. Get the right numbers. Perfect. Hit enter. 48.214. Don't know where my mouse is. There it is. So I get B equals 48.2. That's good enough. This is just a how many triangles question. So let's check for triangle number 1. We've got 35 to start with plus 48. Clearly, we have plenty left over for a third angle. Clearly. Because you just take 180, subtract 35, subtract 48, and you'll have plenty of left over for the third one, third angle. 35 plus, wait a second, we didn't figure out what the other angle could be. Because it could be 140, or it could be 48, or it could be, let's say, 180 minus 48, which is, anybody? Bueller, 132. So, remember, because sine is positive in both the first and second quadrant, it could be 48. Anytime you do a how many triangles question, it's you got to find one angle and then find the one in the second quadrant. Well, let's see. I'm going to add those up because that's kind of close. That's 167. And if I have room for a third angle, 13 degrees, or around 13 degrees. So, answer to this question is, there are two distinct triangles. Oh yeah, this one's going to be really hard. You know why this one's hard? Anybody? Anybody want to guess why this one's hard? Because it's got more than one line of words. Look at all those words. It's like lots of words. I can't even do this one. It's got lots of words. I don't know what to do. I know you're going to figure this out. Oh my god, it's got a decimal in it too. When I have long word problems to do for mathematics, I resort to Brugger's coffee. It's getting kind of old. You're probably getting sick of it. I don't care. I might make millions. Brugger's might call me up and go, man, dude, seriously, you're like the spokesman of the year. A math nerd doing, what'd you just call me? A math professional doing Ruger's commercials. What could be better? Refreshing. All right. At least it's caffeinated. Woo! Here we go. Let's see what we got. Let me grab my highlighter. Grab the highlighter. Let's see. The ski lift is on ground level, 0.7 miles from the base of the mountain. All right, that's going to be right there. So I'm going to put that there after I'm done highlighting. Got the 50 already in there. Ski lift ascends in a straight line at an angle of 20 degrees. Find the length of the ski lift. That would be right here. To the nearest hundredth. All right, let's start putting some numbers. Well, I'll stop putting some numbers in my word problems. So I can find my, okay, 0.75 mile. And this we'll call X. Well, let's see. Do I have any more information in this thing? Remember I told you before, go if you got problems with triangles and stuff, try to find all the angles. Some of you on the last test, by the way, couldn't add two numbers together. Kind of embarrassing, not gonna lie. Don't make mistakes like that. Oh, you guys are amazing. Except for the fact that you can't take 180 and subtract off 50 and get 130. Then I got 130 and 20. That makes 150. 150, and that makes this little angle up here 30 degrees. All right. So let's see. Now we're going to do the law of sines. Well, I mean, let's check to do law of sines. We got, well, we got all the angles, and we got two sides. So it looks like we got a little ASS, maybe a little bit, maybe a little angle side angle. We got a little angle side angle. We can do angle side angle. Got all kinds of stuff. Let's try this. X over, let's see, X is over sine of 130 is equal to 0.75. Now be careful, 0.75 is over this 30-degree angle up here. So sine of 30 degrees. Now I love using sine of 30 degrees because if I had sine of 30 degrees and I was doing this problem, I'd just put a half because the sine of 30 degrees is a half. You ought to know that by now. Cross multiply x times sine of 30, x times a half is equal to 0.75 times sine of 130. Divide by sine of 30. And I'm going to avoid going over to my calculator because I think I have the answer sitting right here on my notes. And I'm going to save a little bit of time. X equals 1.149066, or rounded to the nearest hundredths, 1.15 miles. Law of cosine. Let's see. Let's look at our formula sheet. Oh, yay! They give it to us. It's right here. Right over here next to my hand. See my hand? Grabbing all this. Here's my hand. Now, it only gives us in one form. A, B, C. 2BC cosine A. It only gives us in that form. The thing you have to remember is, and we'll talk about this, is you can use this to solve for any side, not just A or cosine of A. You'll see. So let's give you the two examples. A, B, and C. Little b, little c, little a. And, oh. What if I told you little b was 10 and little c was 14 and little a was 12? And I said, find angle C. Could you do it? Could you do it? In order to lose law of sines, I need to have an angle, because the formula for law of sines, if you remember correctly, over here, law of sines, is I need to have A over sine A, B over sine B, and C over sine B, C. I need to have either any of those two fractions. I need to have three pieces. I don't have a single angle, not one single angle. And then what if I had this situation over here? What if I told you this was A, this was B, and this was C? And little a, no, let's go little, this one is 10, and I give you this is 40, and I give you this is 15. And I say, okay, can you find BC? Well, again, in order to use the law of cosines, you need to be able to put this x over sine 40, and either 15 over something or 10 over something. But I don't have either of these angles, and no way to find those angles. So could you find BC? Nope, not the what we got now. That's why we're going to learn to use the law of cosines. And the law of cosines states that a squared plus or is equal to b squared plus c squared minus 2bc times cosine a. And again, it makes no difference as long as these two match. They could both be the b's. B squared cosine b. What would that mean? Well, that would mean this is a squared plus c squared minus 2ac. Or it could be c squared and cosine of c. And this would be a squared plus b squared minus 2ab cosine c. You can use any one of these forms so long as, and the trick is that the beginnings and the ends have to be the very same variables. So let's do it. Oh, by the way, let's go back to this. So this situation here was side, side, side. And this situation here was side, angle, side. So for side, angle, side, and for sass, and sass, and sass, you're going to use the law of cosines. Let's try. This one, I believe, why did I make it so difficult? Whatever. We're going to use the law of sines, or law of cosines, to find the missing side. Let's see what we got here. Let's draw my triangle. Looks like we're using A, B, and C again. Very creative. I would use K, E, and N. I don't know why. I like those letters better. A. I should change all my homework sheets to K, E, and N. Make a much better triangle. Much better looking. Probably a little balder, but still good looking. Oh my god, I got to slam in 92 degrees. Maybe I should have made this triangle a little bit smaller. 30 minutes, 92 degrees, 30 minutes. And then see, A's here, that's 23. And B, little C's over here, that's 15. And look what I got sass. Side angle side, little sass. Alright, if I have sass. Now, by the way, you could find the area of this triangle. Don't get confused. Remember, we talked about the fact that if you have side angle side, that you could find the area of this triangle using the area formula that's on your formula sheet. But that's not what we're doing. We're trying to find a side. We're trying to find, let's see, what does it say? Use law of cosines to find the missing sides to the, well, I'm not, oh, we only have one missing side. Okay, yeah, we're going to find the missing side. In this case, the missing side is, let's go call it little b. Okay, so the angle I have is b. I'm looking for little b. That's what starts this thing. So little b here, little b squared equals, and off to the end on the right over here, I'm going to write cosine of b. And in between goes a squared plus c squared minus 2ac. Now remember, this is all multiplication here. Be careful with this. Cha-ching, cha-ching, ka-ching. Multiplication. All right. So I don't know b squared. By the way, finding sides using the law of cosines is awesome. Very simple. Very simple. 15 squared plus 23 squared minus 2 times 15 times 23 times the cosine of 92 degrees, 30 minutes. Well, okay, let's try that. 15 squared plus 23 squared minus 2 times 15 times 23 times the cosine of, I have no idea. Oh, 92 degrees, 30 minutes. Let's see, I'm going to have to go on this button. Hit enter. 92 and 30. And hit enter. 784? How could it be 784? I mean, it's got to be the longest side of the triangle because it's opposite going to be the largest angle of the triangle. But not 784. So I'll write this out. 784. 784.0973777282. But that's not what B is. B is equal to the square root of that. So now when I come over to my problem, by the way, I'm not going to type in that number because that's kind of stupid. I'm just going to do control division or control subtract. I'm going to get this square root symbol. And then I'm going to do control, and then see this thing says right here above the minus sign says answer. I'm just going to do control answer. So that basically what I'm saying is I'm going to take the square root of that without having to retype it. I'll hit enter. I get 28.00. 28.00, I think it was 17. And then since it said round to the tenths place, B equals 28.0. And there's my answer. Yay! 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 Math's so much fun! Better stop looking at me at that tone of voice. Y'all making me angry. You wouldn't like me when I'm angry. Come on! I got a green screen behind me, and if I was the Hulk, oh, that would be so cool if I was the Hulk and I was talking to you guys. I think the only thing you'd see is my eyes and my teeth. Because I'd be green, and I have a green screen behind me, so then you couldn't see me. That would be amazing. A is 25. B is 18. Angle C is 150 degrees. All right. And we want to find the missing side. That would be little c. So we're going to put a c squared here. The beauty of this is, the beauty of finding a side is, I just had to type stuff in my calculator. The other ones are, the next thing's a little bit more tricky. So 18 squared, let's see, plus 25 squared minus 2 times 18 times 25 times the cosine of 150. I think I put, no, I didn't put 150. I thought it was 15 degrees, 150. Oh, my back hurts. Getting old, kids. All right, so in order to save a little bit of time, I envisioned, went over to my computer, my calculator, typed it in, came back with 1,728.422842286341, which is a stupid, I will get kids, guaranteed. I guarantee a kid tells me this is my answer. Because they forget to put the squared here. And you have to take the square root. Forgot to do both sides over here. And I get C equals the square root of this. Should be somewhere in the neighborhood of here. Now, since this is a huge angle, it could be probably legitimately double of what that thing is. But it's not going to be like a billion. Probably not quite double. Let's see. 41.5743 rounded to the tenths place. 41.6. That's it. That's all there is to do. You just got to know that you have to use the law of cosines. That's the tricky part. And nobody's going to say, hey, little Shawnee, or hey, little Mary. You got to use the law of cosines. Let's find an angle. Now, finding an angle is a little bit more tricky. Just a little bit more tricky. Let's see what we got here. Let me draw my triangle. All right, we'll start there. A, B, C. And little a is 10, little b is 4, and little c is 8. Now the directions are find the largest angle. Now again, let's go back to a little bit of work we did last year in geometry. The largest angle is opposite the largest side. So therefore, in this triangle, we're going to find A. Since 10 is the largest side, A has to be the largest angle. Now, what do I have here? I have side, side, side. So I have and whenever you have or sass, you got to use law of sines. So, let me write the law of cosines down. Now, since I'm going to be looking for angle A has to start it, A has to end it. A has to start it, A has to end it. So I'll put an A squared here and a cosine A over here. And I better leave myself plenty of room for the next problem. All right. So that means the rest of it's going to be, oh, not that. Let me get rid of that. That's kind of silly. It should be, the rest of it should be b squared plus c squared minus 2bc. Now, in the past, I've worked with kids that have done the law of cosines, and I've tried to do it kind of the same way we do this when you're looking for a side, and it usually just fails miserably. So, since I want to have you guys pass, and I'm looking for A, what I'm going to do is I'm going to solve this equation for the cosine of A. So I want to solve for that thing. Well, that means I got to move this over, and I got to move this over, and I got to move this over. We always take care of our adding and subtracting first. So these two things are going to come over, and when they do, they become negative. So it's a squared minus b squared minus c squared. So those are the first things I'll bring over, this because this is all multiplication, and you can't add or subtract these over. You have to bring them over using division. So the first thing I do is take care of all my adding and subtracting. Then I'm going to go through and get rid of this negative 2bc, and hopefully you'll see an advantage to doing this little bit of legwork right here. First of all, you'll probably get the right answer. So I get that cosine of A is equal to a squared minus b squared minus c squared all over negative 2bc. Now all I got to do is plug my sides in. So let's see, a squared is 10 squared minus b squared, which is 4 squared, minus c squared, which is 8 squared, all over negative 2 times 4 times 8. Now the cool thing is, now I just have to type that in my calculator. So I get cosine of A. Now again, I probably should have forewarned you. Look, you're looking for an angle, and if you're going to look for an angle, eventually you're going to do inverse cosine. So let's just type this stuff in first. We'll get control division. We got a lot going on here. 10 squared minus 4 squared minus 8 squared all over negative 2 times 4 times 8, and hit enter. So I get negative 5/16. Sometimes you get a decimal, sometimes you get a fraction, it doesn't matter, negative 5/16. But I want to find out what A is, so I know that A is equal to the cosine negative 1 of the inverse cosine of negative 5/16. Now cosine you could put in negatives. Cosine you could put in negatives. In fact, you have to, because that will tell you that the angle is going to be in the second quadrant. So I should have an angle that's bigger than 90 degrees in this case. So I will come here and I'll say A equals, and we'll do, I'm going to do the same thing I did before. If you remember, I'm going to do inverse cosine, and sometimes you can just hit the up arrow and just hit enter. Do it that way too if you like, or you can do control answer, doesn't matter. And I get 108.2099. 108.2099. Or A equals, what are we rounding to? Oh, the nearest 10 minutes. Why do I have to be so difficult to myself? Well, if you got that, nice job. But we have to round to the nearest 10 minutes, so we got to DMS this thing. We'll go into our book. We'll click on DMS and hit enter. 108. Now you have 12 minutes, right? It said to the nearest 10 minutes. See it up there? So 108, and the nearest 10 minutes would be 10. So 108, 10 minutes. 108 degrees, 10 minutes. There's our answer. All right, let's get going on this next one. So once again, we have a triangle. Let me see if I can do a triangle over here. A, B, and C. Did I do that again? 4, 5, 6. Oh, I changed these for a reason. So in your notes, or if you have the notes, this is a 4, this is a 5, and this is a 6. Really should make that change. Were you able to tell I just stopped the video and paused it and did a whole bunch of things? I didn't have any coffee, though, while I paused it. I should have. Except I wouldn't make my millions on Brewers coffee commercials. It's getting a little tepid, a little not so warm, not so hot. I like hot coffee. 4. Let's see. B is 5, and C is 6. So I have side, side, side. And I'm finding the largest angle. In this case, the largest angle would be angle C. So that means I have to start with C squared and end with cosine C. A squared plus B squared minus 2AB cosine C. Okay, let's put some stuff in. Oh, wait. We're going to solve for cosine of C. I don't want to start plugging numbers in when I want to find an angle, because that'll cause problems. So I'm going to bring these two over first. Those come over. So I get C squared minus A squared minus B squared equals negative 2AB cosine C. Now I want to bring this over. I'm trying to isolate cosine of C. Negative 2AB. So what I have here now is cosine of C is equal to C squared minus A squared minus B squared all over negative 2AB. I know I haven't looked at you in the eyes in a while. I know you're a little upset about that, so let me look you in the eyes. Because when I look down there, I'm not making eye contact with you. So now I am. My glasses are dirty. I need to replace them. I need to not replace them. I need to clean them. All right, let's plug some numbers in, kids. Now let's do it this way. So cosine of C is equal to, let's say C squared is 6 squared minus A squared is 4 squared minus B squared, which is 5 squared, all over negative 2 times 4 times 5. Go over to my calculator and we hit control division. 6 squared minus 4 squared minus 5 squared all over negative, all over negative 2 times, I have no idea, 4 times 5. Enter 1/8. I get 1/8. Now it's positive. It's positive, so that tells me my angle is going to be acute. It's going to be a smaller angle. So cosine of C is equal to 1/8. Now, since it's small, it's going to be close to 90, but it's not going to be too. It's not going to be too small, but it's not going to be over 90 since it's positive. So C is equal to the inverse cosine of 1/8. So C equals. Let me switch colors. Come over here. I'm going to do this one a little bit differently. I'm going to go cosine, inverse cosine, and I'm going to go put in second answer. Inverse cosine of the answer, I could go up and click on it if I want to, is 82.819. 82.819 to the nearest 10 minutes. Oh my God, I'm killing myself. C equals 82 degrees. Let me DMS this thing. 49.9. Well, to the nearest 10 minutes, that case would be just 50 minutes. That's pretty simple. See, it's 49.9. So the nearest minutes would be 50 minutes. Yay, done with those. More problems. Oh, so here's a little flow chart for you. You're solving triangles. We know we're going to use the law of sines. We'll know we use the law of sines if we have angle, side, angle, 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 side. And the only time you'll use the law of sines when you are law of sines when you have two sides is when you have the naughty two sides. If you have the naughty two sides, you're going to use the angle. You're going to use the law of sines. So when you have angle, side, angle, two angles, use law of sines. When you have two angles, again, law of sines. But when you have the naughty one, this one right here, then you also use the law of sines. Now, for the law of cosines, we've already discussed this. It's or sas. Or sas. That's when you use the law of cosines. So let's see what we got here. Uh-oh, it's got more than one line of words. It's going to be very hard. I don't know what I'm going to do it, man. Let's see. Al. That's where Al's location is. There's Al. Al is 50 yards from a maple tree. Boom, done. 30 yards from an oak tree. Done. His position is shown in the accompanying diagram. There he is. Right there. He's sitting right there. He's like looking at, look, maple tree. Oak tree. Maple tree. Oak tree. Why? Well, let's just say Al didn't pass my math class, and that's what he has to do all day. That wasn't even funny. Okay, it was a little funny. All right. Not funny at all. Sorry. Sorry, kids. Sorry. Anyway, let's see what we got. I forgot what I was doing. Oh, and when he looks from left to right, his head has to swing 120 degrees. So, how many yards apart are the two trees? Wow. Wow. This is like real life math exploding on the screen here. Like, this could solve world problems. Notice I have side, angle, side. I have a little bit of sass. So when you have a little bit of sass, you got to use the law of cosines. So we'll do that. I'm going to call this little a here for little Al. And big Al's over here. That's the angle. So let's see. I'm looking for little a, so I'm going to put little a over here. Little Al squared is equal to, maybe what I should call is one of them m squared, but I'll just do it. B squared plus c squared. It's basically just the other two sides minus 2 times bc times cosine of a. As long as these two match, we're in good shape. So now I'm going to start plugging stuff in. I don't know what little L is. B squared, pick one. It makes no difference. We'll call it 50 squared. Plus c squared, doesn't matter. We'll call it 30 squared. Minus 2 times 50. We'll throw a little 0 in there. Times 30 times the cosine of 120. Now, this side better come out to be bigger. Almost maybe twice as big as 50 and 30. Only because, well, maybe not twice as big. But it should be quite a bit bigger than this 50 degree angle because 120 is the biggest side in the triangle, or the biggest angle in the triangle. So this should come out to be bigger than that. So let's go over to our calculator. No, we won't. I think you guys can type in. Let's try to avoid. Let's speed this up a little bit. I think you get a squared equals, oh wow, isn't that weird? 4,900 exactly. And that's only because the cosine of 120 is a half. And since that's 1/2, it comes out to be a nice number. I take the square root of both sides, and I get a equals 70. Ka-chang! Done. Almost finished. 3 problems left. Yay! Yay! What's this? What do we got going on here? What am I looking for? I want to find the area of this triangle. And I know in order to use, I'm going to do this area of triangle. Area of triangle is going to be over here. We're going to do that work later. I think we're going to do that later. Work later. Area of triangle. And I know in order to use the area of triangle formula, K equals 1/2 AB sine C. C has, the angle has to be in between the two sides. Well, I have one side. Now I have this angle here. I could find this angle. This angle is what, 45 degrees? But I don't have it every side. So I think what I'm going to do is try to find this side right here. We'll call this little c. Now the reason I want to find little c is because then I'll have side, angle, and side. And I can use this. I have the two sides and the angle in between them. And then I can use the area of a triangle formula. But let's see. Let's see what I have to solve for C then. If I want to solve for C, let's see what I have. I have all the angles. So 2 angles leads me to believe we're going to be using the law of sines, not the law of cosines. So I got to be careful here. This is why I put this problem in here. I threw this problem in here because I got to think. I want to find this. Now, the only time I use law of cosines is side, 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 which I clearly do not have, or side, angle, side, which I clearly do not have because I don't have 2 sides. So I can't even use the law of cosines. Again, I have to go back to the law of sines. So, hey, you got to know when to hold them. You got to know when to fold them. You got to know when to do one. You got to know when to do the other. In this case, it's law of sines. So we're going to do C over sine of 45 is equal to 7 over the sine of 70. Yeah. On the Regents exam time, this is what I'm talking about. You're going to have to know when to go back and forth. Which one do you do? So we'll make some flashcards up for that. C times sine of 70 is equal to 7 times sine of 45. Sweet. Divide by sine of 70. Divide by sine of 70. I don't know why I didn't put the sine in. Sine of 70. And I get C equals oops. Can't follow my notes because I didn't do it that way. Doggone it. So let's see. I'm going to have to go over there. Thought I was going to be able to do my notes. So 7 sine 45. So 7 times sine of 45 divided by sine of 70. And I get 5.267. 5.267 41123 41123 514. Now, should I round that? No, we don't round that. Oh, gotta change the directions on this thing to say round. The directions will say, and probably on yours say, probably right in this area right here, say round to the nearest hundreds. At least they should. Round to the nearest hundreds. Should I round it to the hundreds? No. We don't round until the very end, pupils. What we want to do now is come over here and use this law of, or this area formula, and we get 1/2. Now, I just found C. So now I know this to be that 5.26 number. So I'm going to do 1/2 of 7. we're using 7. I'm going to use this side and this side times 5.26. I think you guys will forgive me for not writing that all out. Times the sine of, we're going to use this angle, sine of 65. So sine of 65. Just because I wrote sine of C here and A and B here, got to go back. I'm using this side and I'm using this side, so I have to use this angle. All right, so let me come over to my calculator. I'm going to do 0.5 times, and then I'm just going to go up here and enter that thing, times 7 times the cosine of 65. I don't think I can type in cosine. Times, you have to actually type in the angle. Because if you type in cosine, I think it's like the angle cosine, or it's just the variable's cosine. 65. 7.7. That's interesting. That's different than I got before. Interesting. Oh! Did you see my mistake? Anybody find it? I can pause this, or you can pause this if you want to look at it. Sitting right there next to my arrow, a little bit to the right. Okay, this is one of the issues with dealing with this. Take a look at this line I wrote right here. I get so wrapped up in the law of cosines that I wrote actually cosine there, and this should be sine of 65, not cosine of 65. And we get 16.708. That's what I got before. Thank goodness I hit an answer key. I probably would have had the wrong answer there. You all would be upset with me. Let's 7086 something something something. So the area is equal to 16.71. There it is. Woo! Caught my mistake. Sweet. 2 left, right? 2 left. Oh my gosh, this is amazing. Oh no, it's got more than. Oh no, it's got more than one line. Draw a triangle. Oh no, this one's more fun to draw than that. I forgot which problem we're on. All right. We're going to build a tunnel through a mountain. So we're going to have a tunnel. And it's going through a mountain. There's our mountain. I think I missed my calling. I could have been an artiste. I think so. So let's see what we got here. They said that the beginning of the tunnel is going to be A and the end of the tunnel is going to be B. Well, that makes this probably up here C. It says angle ACB. So I guess the surveyor is sitting at the top of this mountain and he goes, oh, that's a 110-degree angle. It's all for estimations here. They somehow measured their time up to be, and measured this up to be 3800. And then they measured it down to be 2900. They want to know what little c is. They want to know what is the distance of this tunnel. Rounded to the nearest meter. Doesn't have to be that accurate. So, we have side, angle, side. SAS. And if we have SAS, we use the law of cosines. So, we're finding little c. So c squared equals a squared, that squared, plus b squared, minus 2, I gotta get a new computer, ab cosine of c. We don't know what c squared is, so we just type in all the other stuff. 3,800 squared plus 2,900 squared minus 2 times 3,800 times 2,900 times the cosine of 120. And somebody in the back, D-Rich, is probably saying, isn't that just 1/2, Mr. Krause? Yeah, that's 1/2, so we should end up with a real nice number here. Maybe, maybe not. Oh, it's not 120, it's 110. Well, okay. No, D-Rich, you're wrong, it's 110. Sorry, bro. Not going to be so nice. So, let's see if we can get this on our calculator. 3,800 squared plus 2,900 squared minus 2 times 3,800 times 2,900 times the cosine of 110 degrees. Bam! 30388. So remember, it's c squared. So you're going to get some huge numbers. 30388,123.9589. Can you believe I memorized all that? Taking the square root of both sides. Now notice this is 110 degrees, so this better be bigger than either one of those two, because that's the biggest angle in this triangle, and we get 5512.542422, or round to the nearest meter, C equals 5513 to the nearest meter. Yay! One more problem. A hiking trail is planned in the shape of a triangle. Oh my God. Who would have guessed? I wouldn't have guessed. I would have been like, no, not a triangle. Why would it be a triangle? We haven't done anything with triangles. Hiking trail. Oh, so I'm traveling on my hiking trail. Going along my hiking trail. And then I want to go home because I'm tired along my hiking trail. There's my hiking trail. We'll call it A. Oh, we're back to A, B, and C. We got to do the last try. What is the last one here? The little doohickey. What is this little doohickey in my southern accent? Because I know how much y'all appreciate it. Let's try to put those numbers on there so they make a little sense. Let's go 6.2. That's like the middle. This one's a little side, 2.3, and this there, that trip home, man, whole one mackerel, that's 8.1 miles. Find the nearest tenth of a degree, the largest angle. Largest angle is opposite the largest side, B. So, little b is going to go over here, big B will be over here. I'm glad we're looking for B, because B is fun to say when you're doing the country accent, see what I'm saying? Oh my gosh. See, my computer's running out of memory, and it's having a hard time dealing with my pen now to a... What in the hell am I doing? Did I just say the H word? I apologize, Mom and Dad, if you're listening. I'm really not that bad of a teacher. Well, okay. Never mind. A squared plus C squared minus 2AC cosine B. Now, whenever we're going to look for an angle, I want you to isolate that angle. So we're going to do B squared minus A squared minus C squared. Hopefully by now you know we're going to eventually just divide by negative 2AC to get cosine B. So that's how we isolate. We bring these two over by subtracting them, and then we're going to divide by this. All right, that's not too problem. Let's put some stuff in. Cosine B equals, I just like having that on the right side, on the left side, equals 8.1 squared minus 2.3 squared minus 6.2 squared, all over negative 2 times 8, not 8, damn this. 2.3 times 6.2. And you all know, and I know you're thinking there, don't forget, you're going to be doing inverse cosine. All right, let's see what this crazy thing is equal to. Control, division, and then we're going to do 8.1 squared minus 2.3 squared minus 6.2 squared all over negative 2 times 2.3 times 6.2. Is that right? 6.2, 2.3. Do I get all those right? I hit enter, and I get that crazy thing right there. Well, I'll write it down. It's negative, so you know our angle is going to be bigger than let's see, 76718095. You know it's going to be bigger than 90 degrees. We're going to do the inverse cosine of this. Let's just do it. Getting old. Trig. 1, 2, boom. Inverse cosine of that answer. We'll do inverse cosine of that, and we get 140.101. 140.101. 408. But we got around to the nearest tenth of a degree, so we get B equals 140.1 degree. And that is all she wrote for the Law of Cosines practice work for today. Rock on, kids. There we go. Have a good day. Have fun storming the castle. And don't forget to subscribe. Hit the subscribe button. I think we're up to 104. I'd like to get up to 200 by the end of this year. Maybe 3. I think when I start doing the review assignments, maybe we'll get to 3. We're going to need your help. Hit that subscribe button. Peace out, sister.